All right, that's awesome. It's a great pleasure to be here to talk about a topic that definitely I'm keenly interested in. I'm sure a lot of other people are interested as well. I want to talk about, a lot of times we talk about agility, we talk about agile development. I work with a lot of different clients, and when I walk in, one of the first things they want to tell me is, we are agile. And I often tell them, I'm so glad we got that out of the way. Now let's talk about what you actually do. And so what I want to talk about is agility, but one of the part of agility is what I call as sustainability. And sustainability is something extremely important for a lot of us because we can't really be agile if we can't sustain the pace of development. And in a world that is changing very constantly, we really definitely have to do anything and everything we can do to sustain it. And that's what I want to talk about. But before I talk about that particular aspect, let's talk about what we see around us. Well, we live in a world of buzz. We have a lot of different buzzes around. And so what are some of the latest buzzes that we hear about? Well, I've been kind of listening to a few things that I've been hearing about. One of them, of course, is microservices. Well, we can't get by a day today without hearing about microservices. Everybody suddenly wants to build microservices. And then we hear about big data. Everybody is talking about big data. Cloud, of course, everything is on the cloud. How could we escape that? And of course, Docker, or is it Moby? And then, of course, we hear about functional programming quite a bit. It's been around for a very long time, but suddenly it's a new excitement. And then, of course, it's Angular 2, or is it Angular 4 already? And then, of course, then we hear about IoT, we hear about AI, and it really draws smiles on my face when I think of the word algorithm. Because you know that something has become a total buzz when you hear the word algorithm in TV shows these days. Everybody wants to talk about algorithms all of a sudden. And then, of course, machine learning. And recently I was told machine learning is so obsolete. We're now talking about advanced machine learning. I don't have a clue what that is, but that's what we want to do. So we live in this world of buzz. We want to be always catching on to the next big thing, always looking at things what everybody else is doing. But what is this really leading us towards? I started programming a good, I don't know, maybe 35, 40 years ago. And I look back at the time when I had to learn programming to the time now people in schools and colleges having to learn programming. Honestly, it's overwhelming. It is absolutely phenomenal in terms of how many stacks of abstraction we have built upon. And the things we have to learn, things we have to know, it's just incredible. So we are dealing with higher levels of abstraction. As we are building more and more larger and larger systems, how do we really survive that kind of complexity of what we need to be building? And I think this is one of the most interesting things. If I look back at my own career programming for a few decades now, all I can think about is those times when it hurt me the most. And those were the times of paradigm shift. Paradigm shifts are really hard for us because it really requires us to change our way of thinking. We have to rethink about how we solve problems. And there's been about maybe 3, if not 4 different paradigm shifts I've gone through in my career. And I think we are, again, to a paradigm shift right now. This paradigm shift is not new. It is just that it's newly being adopted, but it's been around for a very long time. But looking at the paradigm shifts of the 90s was predominantly into object-oriented programming. Before that time, we were pretty much building systems using procedures and structured programming languages, but we generally adopted to object-oriented programming pretty widely in the 90s. And we went from the structured programming to the object-oriented programming mindset, and almost every single system and libraries and languages we've been using since have been object-oriented one way or the other very, very significantly. But in terms of the latest paradigm shift that we are going through right now, like I mentioned, is not new, but it's just that we are beginning to adopt it. So you may wonder what it is. And I'm going to say that is from imperative to declarative style of programming. And I want to outline this because we have this buzz about functional programming right now. And I feel that it really misses a very important point. It's not really that the functional programming is really that awesome, that there is something very underlying to functional programming that really makes the difference. So my excitement, honestly, is not about functional programming. My excitement really is around declarative style of thinking. And I'm saying declarative style of thinking because it's not just about programming in declarative style, but beginning to think in a declarative style. I'm going to outline of places where we see this almost consistently in almost every aspect of what we do, not just in programming, but also in the way we live our lives as well, and how we interact with societies. So why not functional programming? Well, the reason really is, in the imperative style of programming, you talk about what to do, but you also focus your effort on how to do it. An imperative style of programming has ruled the world. Almost every single one of us in this room has spent a lot of time and effort programming an imperative style. I spent my youth learning imperative style of programming. That tells you I had a terrible childhood. And it was that we programmed in imperative style for a long time. And unfortunately, imperative style of programming is inherently more complex. And we've been dealing with a really poor choice of a tool given to us. In the declarative style of programming, we tell what to do, but then we let the underlying libraries and tools figure out how to do it. This is a very fundamental shift in the way of thinking, not just in the way of programming. And it turns out that functional programming is actually declarative in nature. Not all declarative code is functional, but all functional code is declarative. So one of the biggest strengths in functional programming really comes from the declarative nature of programming. And a lot of times when developers don't think about it and instead rather focus their time and effort on functional style, it gets a little frustrating. But once we get the idea that we really are trying to be declarative rather than being imperative, our line of thinking immediately changes quite nicely. So then what is the relationship in these two? Well, the relationship really is that the functional style of programming is actually declarative style plus the higher order functions. So it really is a mixture or a marriage of these two things that really brings this effectiveness into it. So anytime we program in functional style, not only do we use higher order functions, but we also pretty much focus on programming declaratively as well. But this is not just in programming, but we can see this pervasive in almost everything we do. So let's just spend a little bit of time thinking about what the difference really here is. In the imperative style of programming, we tell what to do, but we also have to spend the effort telling how to do it. So here's a little example to think about. I have a list of names right here. Let's say the problem given to us is to count the number of names which are, let's say, 4 letters in length. So that's what we want to really do. Very simple problem if you really think about it. But how much time and effort do we take to do something like this? Well, first of all, you start with a little variable called count. Eventually, you want to display the value of count. But between these two, you're going to start with a for. And we have tools given to us, and we deal with a lot of different tools. But this is what we normally do, is deal with these different tools to get our work done. You could start with, for example, I equal to 0. Then, of course, you say, is I is less than, and then you struggle, is it less than or equal to? You have to go through all these details of complexity. And instead of doing all of that, thankfully, we can also use a few simpler constructs. We could say name, and then, of course, of names. And then within this, of course, we could say if the name dot length is equal to 4, then we could say count is count plus plus, and that gives us a result of 3. Not only did this require a lot of typing, it required a lot of doing. We had to control the loop. We had to tell how to really go through it. We had to branch and do a lot of these things. This is inherently a imperative style of programming that we are so used to when it comes to programming, and that can be really, really annoying in terms of how we have to get the work done. But the complexity really comes from these things. Complexity comes from having to deal with all these low-level details in our code almost constantly. But rather than doing this, the declarative style keeps our focus. We are able to convey what we want to do, and we let underlying libraries do things for us. In a way, if you really think about it, The imperative style of programming is like talking to a toddler. When you first talk to a toddler, it's very exciting because you are like, wow, I was able to talk to this toddler. It was so much fun. But the second day you talk to the toddler, you begin to realize it's not going to be fun anymore because you got to repeat the same damn thing again. And the third day becomes the same thing, and the fourth day becomes the same thing. And then you realize this is going to continue for the next 18 years. That's called parenting, isn't it? That's how it feels when you program in the imperative style. Well, with the declarative style of programming, we can focus and tell what to do and let the underlying libraries figure out how to do it. So for example, in this case, we could simply start out and say names.filter, and given a name, I could simply say name.length is equal to 4, and then I can simply ask for the length of it and get the work done. So the point really in this case is we can keep our focus on what we want to do, and we can use better tools to get our work done. And in this case, of course, it's the filter tool, and similarly map tools and reduce tools and these constructs, but this is really the declarative style that is really shining right here. Of course, this is a JavaScript, and JavaScript incidentally has been doing this for a good 20 years. But one of the reasons why we haven't really exploited this is, especially with a language like JavaScript, most of us were programming not just in JavaScript, but we're programming in JavaScript and yet another language, like Java or C# or what have you. And because the mainstream languages did not support functional style of programming, most of us, the developers, had to become comfortable with doing similar things on both sides. So we gravitated towards more of an imperative style on JavaScript as well, even though the language has supported this for a very long time. But now that most of the mainstream languages are beginning to support functional style of programming, we are able to enjoy this a lot more easily in JavaScript as well. But this is just at the programming level, and that is declarative in code. But we can go a lot further than this. We can see this take effect in almost every aspect of our lives, including front-end programming. For example, let's say you want to program the front end. How do I write the code for programming the front end? So here's a little example. And what does it really mean to create a rich environment for programming the front end? Well, typically you are manipulating the DOM. So here's an example of a piece of code. I'm saying document.getElement by ID, and I ask for a little element whose ID is called greet. And once I get it, I create a Tom as a variable, and then I say, Tom, how are you? And I set that into inner HTML. This, of course, we know as manipulating the DOM. How many of you have manipulated the DOM before? Of course, everyone here. But how many of you want to do it again? Not a single hand I can see up. Because the first time you manipulate the DOM, you quickly realize it's a work that should be given to people in the prison. Nobody in the free world should be forced to do it, right? Because it's no fun. It's too low-level detail. It's a horrible way of programming. And some of us did this, and some of us still do it very quietly. We just don't, announce this in public. So this is really a lot of work. This is an imperative style of programming on the front end, and very quickly we struggle to move away from this. Well, what could we do differently than this? Well, we could try to use jQuery, for example. Now, jQuery, of course, puts a little $greet. We didn't say document.getElement.id. And then what did we do? One of the complexities of the imperative style is not only to do all of this work, but you also had to know what the properties were, the methods were for different things. And honestly, I could never, ever remember this. Is it click or on-click, or is it checked or unchecked? I'm not smart enough to remember all of these details. I just suck at it every time I get to it. Well, jQuery said, I'll give you a set of convenience functions to use. But in all honesty, jQuery is like taking morphine to reduce your pain. It didn't remove the pain. jQuery still is imperative style of programming. It's just a little bit, a wrapper around things so you don't have to struggle that hard. But then where are we today? Well, we are moving towards something like Angular. And in Angular, what we are doing is we are saying selector is greet. And then you say the template, and you specify what the content of the template is. Well, notice the clear difference between this code and this one. This one here is imperative style of programming, whereas this one here is declarative style of programming. You simply said, I have an element whose name is greet. I have a content, which is the template, and that's it. You told what to do, but you'd let the underlying library figure out how to actually do it. This is a consistent theme that we see in development today. So what does this really feel like? Well, I'll give an analogy to what this feels like in our lives. I am, in all honesty, not a fan of cars. I have friends who are really big fan of cars. I've got children who are big fan of cars. I just don't care about cars personally. When I go to a rental car company, they often ask me, what kind of car would you like? I say, I would prefer one with wheels, please. That's how much I care about cars. I just don't care enough about them. You will never, ever catch me drive a stick shift. That's just not for me. That's way too much cycles in my mind to be focusing on driving, which I don't care about. So I don't really care to drive stick shifts, though there are people who really care about it. Programming with the DOM, programming imperatively, is like driving a stick shift. Not so much fun, in my opinion. Then, of course, you could use auto transmission cars. I have an auto transmission. I can put it on drive, and I can just focus on, steering. At least I don't have to mess with the gears and the clutches. I don't have to worry about it. I still have to keep the focus on my street. I still need to manage the driving. So that is like auto transmission. I would say jQuery is your auto transmission. You're still doing the work, but at least it removes a burden on you. But a couple of weeks ago, I was in a Tesla. And I have to tell you, I am sold already. I got on the freeway, I set the maximum speed to 70, I put it on auto drive, and I took my hands off. And I was just sitting there and driving, and of course, not really driving. That's the fun part of it. And after a while, it said, are you still awake? And it just kind of beeped at me to make sure. I hold the steerings a little bit, and then it said, okay, you're still awake, let go, and I had to let go. And of course, it adjusted speed accordingly, and I was able to change lanes automated. It was wonderful. Well, okay, I'm not there yet. It's still not fully available yet, but they're getting there. But what do I do in the meantime? Well, I'm an Uber or a Lyft kind of guy right now. And that is one of the things I really like a lot. I arrive at the airport. It doesn't matter time of the day or night even. I walk over to the curb. I find an Uber or a Lyft. I get in, and I tell the person where to drive. And then I sit in the back of the seat, and I do what I like the most, to write code. I don't want to be doing the driving. I just tell them where to take me. The driver does a much better job navigating the cities. And trust me, it's better the driver drives than me drive, if you know how I drive. And the point really is that I'm more of a person who sits in the car and have somebody else drive me. That to me is like a declarative style of programming. So you simply tell where you want to go. You're not doing the work of going there and let somebody else take care of it. And that's where the world is heading towards, is a declarative style of programming, declarative style of living, in fact. But how does this really impact us? And the point I'm getting back to is we are living in a world where we are no longer going to be programming at the lower levels for very long. The level of abstraction has already increased, and it's only get even more higher as we go through. And as we do this, the code we're writing is going to become a lot more expressive. It's going to become a lot more concise. The code is going to become a lot more easier to maintain, and it can support rapid change. But the question is, now that we are sitting on a very tall stack, how do we really deal with all this complexity? And it really comes down to economics of software development. We cannot be developing at the low level every single bit. It just simply doesn't make any sense. So we have to gravitate and move towards this direction, no doubt about it. But let's talk about how the world is changing. A lot of us program in Java. I program in Java or the JVM languages quite a bit. But I've also been programming in JavaScript for a few decades now. And slowly but surely, I'm doing a lot more work in JavaScript these days as well. But let's talk about JavaScript for just a little bit, because some of the things I'm going to talk about is a problem in Java as much as any language, but it just simply aggravates in languages like JavaScript. But what is JavaScript? I'm going to say JavaScript is a great example of a black swan. A black swan is an idea or a concept or just about anything you never knew exists, but suddenly becomes so prominent. Did anyone ever expect JavaScript to become such a serious language? Even the author of JavaScript did not think that it would. And it's just amazing how one day you wake. Imagine this was the year 1995, and somebody asked you what language you think would be more popular and people will be talking about in 2017, would you have ever imagined to say JavaScript? And had you said JavaScript, what would people think of you? They would say, are you crazy out of your mind? But that's just amazing how it's turned out to be. But what is really JavaScript, though? How many of us use JavaScript in one way or the other? How many of you like JavaScript? Well, fewer hands stay up, right? I know the feeling for that. Well, I think there is a reason for it. JavaScript is an extremely powerful tool. I can't think of a language that is as powerful as JavaScript in terms of its capabilities, but JavaScript is dynamically typed, but JavaScript is also weakly typed. And the weak typing of JavaScript also becomes a burden. I was programming with JavaScript the other day, and I had made a certain small change, and the next thing you know, I had no clue what was happening anymore in the application. So that's why I did this, and this is a true feeling I have about JavaScript, because I really like JavaScript. And the true feeling I have about JavaScript is that JavaScript is like an infant. It is cute to play with, but you have no clue when it begins to cry. And that is so true in a lot of different ways, because once the language begins to misbehave, you're like, Mom, this kid is crying, I don't know why. And then you go through this checklist of things. Did you feed it? Did you make sure the diaper is changed? You got to go through a set of debugging to figure it out. It can be very frustrating, because there is one thing that I've understood very clearly. You never use the word JavaScript and logic on the same sentence, because there's no logic when it comes to JavaScript. And so when it comes to writing code in JavaScript, how do you deal with this? It's a very big slippery slope. It's a very powerful language, no doubt about it, but you got to really be very careful using this language, otherwise it can hurt us really bad. And when it comes to this, we are mixing this kind of scariness and power in our hands with agility on the other side. So let's now talk about agile development. So what is agile development? Well, agile development is responding to change. Oh, well, wait a minute. That's not just responding to change. It is responding to change even late in the game, which means anytime anybody could come to you and say, gosh, we really want to change this, and you must be able to accommodate those changes. So how in the world can we accommodate change late in the game and survive it, and how can we really sustain it? So in this case, what does it really mean to sustain this? And so this is my observation. You go to a developer and you say, I want you to make these changes, I want you to make these enhancements, I want you to fix these bugs, and I want it tomorrow, or maybe later today. And the developer goes around and makes all these code changes. And then when you go to the developer, you ask this question that everybody hates being asked. You ask the question, does it work? And usually it is evoking a response called, I hope. And this is a sentiment we all share. And I've been struggling with this, and I finally figured out there is actually a technical term for that particular way of development. It is called JDD. It stands for Jesus-driven development. You put hope in the faith of the Lord, and you say, dear Lord, please stay with me. I have written this code. My boss is on my tail. I've got this code to work, please. So we all do JDD every single day. But I think we should really let the Lord do more important things there is to do in our world, and let the stinking code be right to ourselves. So I like to really do TDD rather than doing JDD. But even the TDD has different connotations. I was with a company recently, and they said, we do TDD. And I said, I don't get it. How do you guys say you're doing TDD? And they said, well, that's called threat-driven development. I don't like threat-driven development either, where somebody says, you will do this otherwise. Well, I think we should really be a lot more mature about it. How can we do this? So I was, one morning, I wanted to really go to a travel site and get my boarding pass. And when I went to the get the boarding pass, I won't mention the airline right now, but when I fly very often, and all I can see in the airline's website when I went to check in was all these curly braces on the HTML page, And I remember saying, oh, you're so cute, you're using Angular. I really wish I had taken a photo of it. But the next morning when I realized it, instead of taking the photo, I made this tweet. I said, don't bother testing your software. If it does not work, the users will tweet about it. Well, we live in this world where we cannot be developing poor quality software because it becomes more visible today. How do we stand behind the code we write? How do we make sure it's actually working? So I've also come to realization about what we are as software developers. It's a little grim, but I think most of you will agree with this. So who is a software developer? And I'll tell you who a software developer is. It is a person, a profession where people get paid to write poor quality code and get paid more later to come clean the mess. And this is a great profession to be in. I mean, why would you not want a job like this? You can screw it up today and get paid to screw it up more tomorrow, right? And we have fundamentally changed the way we do things because we have to become professional. We have to really think about our job as a profession and say, no, we cannot be writing code like this. We have to do a lot of things differently. Sure, we have pressures from the organization, from the management, from the company, from the requirements, from the users, but we have to really turn into professionals. How do we go about doing it? How could we become better software developers over time than being this definition of software developer, where we are getting paid to write poor quality code and then get paid more to clean up the mess later? So we have to rethink about what we do. This is one of the areas where I care about a lot, and I spend a lot of time and effort on testing. And I'll be honest about this. I always worry about what I say. I always think about what I say. And I ask myself, is it something I would do if my money was involved in it? And I'll tell you where I firmly begin to realize and benefit from this, because I used to work for a lot of different companies. I used to work for a lot of different clients. And it's easy to really say things when I work for somebody else. But over the past few years, I've been writing software for my own company. And when I write code, the person who is paying for my time writing the code comes out of this pocket right here. And if I mess up the code I write, I have two choices. I can spend the night fixing the code I wrote, and if I'm spending the night fixing the code, honestly, I would rather spend the night doing more fun things like writing new features than fixing the mess I created. Or I could hire somebody else and say, here, take my money away and clear the mess I created. Neither one of them is an option. So when I started writing code for myself, I quickly realized that I'm actually spending a lot more time writing tests much more rigorously. And I was struggling to understand my behavior in this case because I was extremely tight on budget. I didn't have time. And that's when I came to this realization. I like to automate my tests, not because I have a lot of time. It is because I don't. And this is one realization I came to eventually, is that I'm doing stuff the way I do, not because I have a lot of time. Time is one of the most precious things you ever can have. And I do things a lot more efficiently, not because I have a lot of time, but it's because I don't have a lot of time. And time and again, spending the effort, doing this right, has come back to pay dividends in a very huge manner over time in terms of time, not only saving my time, but also improving the reputation as well. I remember very clearly, one Saturday morning, I wake up in the morning, I had a client here in Europe who emailed me and said, hey, I'm looking at your app. It would be so nice if you just gave me this one feature. It was about 5 in the morning on Saturday. I just got up early. I looked at my watch. I have 2 hours before the family is going to wake up and start running. And I said to myself, why don't I just spend some time working on this? And I want to emphasize this is arrogance, but about really knowing what we are doing. And so what I did is I ran all my automated tests. Everything passed. I wrote a few tests for this new feature the person wanted, ran all the tests, and made sure all the tests are passing, checked in the code, pushed into production, never actually ran the application manually to see if it's working. Within about 3-4 hours, I get an email back from the person saying, exactly what I wanted, thanks for doing this. And the point really I'm getting to is, when we can do automated verification, we can get that confidence and agility. And to me, agility is not words that I speak, but the life I live in the way that I do things. That's extremely important for me. So given this, what about testing? I want to start out by emphasizing that I truly love manual testing. And I want to emphasize this, I truly love manual testing. But I want to emphasize also what I mean by the word testing. To me, the word testing really means it's an act of gaining insight into applications. Now, this is one of the sad things. People often argue, are we taking the job away from testers? No, we are not taking the job away from testers because we never gave them their job in the first place. And that is the sad part of this, because we've been asking them to do stuff they shouldn't be doing in the first place. The job of a tester is to really gain insight into the application. Is it usable? Is it intuitive to use? Is the workflow really useful? Should it be doing something else? What are the features missing in there? Should we really be changing the way the user interacts with this application? There is so many things that we need to focus on from the point of view of testing, and to me, that is really what testing is. But I want to really think about the word test versus verification. Testing is an act of gaining insight. Verification is, on the other hand, something extremely different. Verification is asking this really mundane question, does it work? And if you really think about it, this is what we do about 95% of the time. You modify the code, and the question is, does it work? The code worked yesterday. Does the code continue to work today? And there is a strange behavior in the code. And I'm sure you have seen this as much as I've seen it. The code always does what you type and not what you mean. How annoying it is. And then when you go back and look at it tomorrow, damn it, that's not what I meant. I meant it to be less than and not less than or equal to, or +7 rather than +8. All these things that come to annoy us and haunt us, does it really work? And I'm going to say that no human should ever be asked to manually verify if the code works. I take that as an insult on humanity. For somebody to go to a fellow human and say, can you verify that that code works? That's a poor form of respect, not to that human, but to the entire human race, in my opinion. Because no human should ever be subject to this. Does it actually work? That is the job of applications and systems and computers to tell us, not for humans to waste their creativity and time and effort to determine that something that worked yesterday continues to work today. So test manually, but verify automatically. And that is one of the reasons why automated verification, called automated testing, is really so important. Well, we can all agree that automation is critical, but how are we getting there? So I work with a lot of different companies around the world, and this has just been my observation learning from these different organizations. And I've found out that there are 3 different groups of companies out there, or I would say 3 phases of verification. The first phase is no automation. These are companies in denial. They're like, we're cool, we can just do this manually and verify this works. And they're in denial. They're just facing really, really slow death, or maybe accelerated death, depending on the industry they are in. It is impossible to keep up with the demands of the application by manually verifying if the application works. So I used to be in this phase in companies I worked with. I've realized that that's not the place to be. I've moved on very quickly. Then there's the second phase, yes to automation. Oh, of course we need to do automation, no doubt about it. But this is where the challenge comes in. There is cases where we want to automate, but what do the companies do? They go hire somebody with really beautiful titles. One of those titles is called automation engineer. What a beautiful title. So automation engineer Joe walks into work and says, hey folks, I'm your new automation engineer. What does the programmers in the team do? They are very busy fixing bugs, and they say, hey Joe, welcome to our company. Now leave us alone, don't bother us. We are busy here, we don't want to talk to you. So what does Joe, the automation engineer, do? Spends a few weeks looking around the team and notices the programmers are nose down, very busy working, and everybody is doing their own stuff. And what does Joe, the automation engineer, do? Scratches their head and says, what in the world? What do I do now? And goes to the programmers, and the programmers are like, don't talk to me now. I have no time for you. So in the meantime, the boss comes to Joe and says, so Joe, how's it going? I want to see some automation in work. What are you going to do? And Joe is stuck between a rock and a hard place. Joe has to automate, but programmers don't want to talk to Joe, so what does Joe do? That's when you start hearing the words like selenium. And when you start hearing words like selenium, I come to this realization. UI level, mostly UI level automation has a really good technical name for it. It's called the pathway to hell automation. And this happens a lot in companies. When I go to companies, they never seem to use the present tense when it comes to UI level automation. They often use the past tense. When we used to write all these automated tests, I'm like, why do you say used to? Oh, we used to have thousands of tests running at the UI level. Then these damn programmers changed all the user interfaces and nothing works anymore. We don't have time to keep up with this. There was one exception, though. I had a client of mine down in Texas, and they said, oh, we do this. We hired a company out of Vietnam. They're doing a really good job. This works. I said, no, it doesn't work. Oh, no, it works really. Let me show it to you, this gentleman said, and takes me to his desk and shows me a system doing automation at the UI level. It was like a ghost sitting there and playing the application. You could see an unseen hand type into the keyboard, and characters appear, and then things change on the screen. He said, it's a little slow, that's all. I said, how slow is it? Oh, it takes about 12 hours to run the suite of tests. But it's beautiful, it works. I said, are you really sure this works? Oh, absolutely. I said, you know what? I speak in conferences. If this works, the world needs to know about this. So I'm going to submit a talk on how to rocket automation in the UI level if you will teach me all your secrets. He said, I will teach you all my secrets. This is going to change the world. So I said, I'm back here in your company in 6 months. Let me schedule an afternoon with you. I'll be your student. You teach me everything. Let's just do this. Absolutely. So 6 months goes by. The day comes when I am in client side. I go to him and said, remember we had this talk. Can we have the half a day that you're going to teach me all this stuff? Oh, those damn tests. We haven't run them in 3 months now. I'm like, whoa, what happened? Well, they drastically changed the UI and none of the code test is working. We don't have time to fix it. Well, I thought there was a hope finally there, but unfortunately, no. And this is a repeating theme I see over and over. Just to share one experience about it, this was back in January a couple of years ago. I had a client of mine who has offices in the UK, has a testing team here in Poland, and the boss calls me on the phone and says, I've got a tester here in Poland who is having trouble automating this test. Would you please help him? So we are on Skype. I'm in Denver, Colorado. The boss is in the UK, the tester here in Poland. We are on a three-way call, and the tester explains to me what he's doing. And after listening to him, I told him, I got a suggestion for you. Don't do it. And go talk to your developers, sit down with them, find out how to reach one level below the UI and do the automation testing. Don't test the UI level. This was in January. Then in I was actually physically here, spending a week at the client site here in Poland. And when I went in, this tester came to me and said, do you remember we had a talk back in January, and you told me not to write those tests at the UI level? I said, of course I remember very clearly. He said, I've been doing it since that time. And I said, well, that's interesting. How's it going? He said, it doesn't work. I'm like, well, if it doesn't work, why are you doing it still? He said, that's okay, don't worry about it. I know you're coming here this week, so I saved the Thursday, it's you and me. I'm like, oh my dear God, can I die before then? And so it was Thursday in the morning, I sit down with him, and I'm not kidding with you, I never felt so stupid in my life before. Because we spent 4 hours, and this one little test would not work. And here I'm telling, don't do it, and here's the tester who says, do it. And they say the customer is always right. I don't know whoever said that should be shot. But the point really is I'm sitting here trying to figure out how to make this work. And then we do this manually. You go to this little item, there's a little list box, you click on the list box, a list box shows up, you select an item, the list box folds, and the content on the right side changes. Beautifully, it works. He has written a Selenium test for it. I look at it, it doesn't work. After a little bit of struggle, I tell him, oh my gosh, I know what's happening. He's like, what is it? Well, when you click on it, it's instantaneous to your human eyes, but humans cannot see changes too rapidly. It takes 250 milliseconds for a human to know of a change in front of us. That's why you don't see the fan blade spinning when it spins. Our Selenium test is wicked fast. It is querying for the results before the JavaScript had time to respond to it. Let's put a little sleep. So we put a little sleep in the code. And guess what? The test passed. He jumps out of the seat and says, it works. I'm like, no, sit down now. You're not supposed to do this. And it took me the rest of the afternoon to convince him, no, please don't do this. And the point is, it's extremely brittle. And we spend way too much time doing this. It's pretty pointless. There is a name for it. We live in a field where we are the most amazing people in the world, the developers, because we'll do absolutely stupid things, but we'll give a nice, beautiful pattern name for it. It doesn't feel bad anymore. So this stupidity I talked about has a beautiful pattern name. It's called the ice cream cone pattern. The ice cream cone pattern, if you Google for it, you'll find about it. And the ice cream cone pattern is where you do a lot of tests in the top levels and very little test in the bottom level. This is the current industry standard. This is what people are doing mostly when it comes to test automation. They are living the life of pathway to hell by doing the ice cream cone pattern. We should definitely run away from this. And this is very largely ineffective. What we really want to do is what fewer companies are doing really well, and that is right level of automation to the right degree, to the right measure. And this also has a name. If you Google for it, you'll find it. It's called the test pyramid. And test pyramid, and many people have written about it. Mike Cohn has written about it in his book. Martin Fowler has talked about it in his blogs as well. So the test pyramid is where you do the right amount of test at the right level. Now, I care a lot about automation testing. I care a lot about integration testing. But to me, I don't want all the tests to be in the integration level. I want the test to be at the right level for the right reasons. And this is something that can give us a lot of different benefits. But why is it so hard? Now, I believe a lot in writing test first. Write test and then write code. That is something that I believe in a lot. But then I realized it's really hard for two reasons. The first reason why this is really hard is when you hear people tell you the code is hard to test, what they're really telling you is the design of the code sucks. If your code sucks in design, it's really hard to automate the test for it. That is one of the reasons. The second reason why this is so hard is something that took me a while to realize and figure out. And the problem here is when I go to developers who are really smart and I tell them, here's a problem, go implement it. They go away and within a few hours they come back and say, here you go, here's a solution that works. Well, awesome. Then you go to the same developers and you say, here's a problem, but don't write code. Write test first and then write code. And they look at you like you're stupid and say, are you out of your mind? How can I write code? How can I write test without writing code? And so it really baffled me. Why can't smart developers who can write code not write test before writing code? And eventually I realized there is a really good reason for it. And the reason is, how do we actually write code? Is there anyone in this room who is given a problem and you just sit down and say, I'm going to write code. And then you just type it and everything works. And then you just get up and walk away. Is there a person like this in this? Do we have such a divine presence in this room? Nobody stood up, right? That's not the way we write code. How do we write code? I'm going to try this. I'm going to try this. That doesn't work. Let me try this other thing. Damn, this doesn't work. How does this work? Well, that almost works, but not quite. We struggle through it, and then eventually it works. So what is programming? So I'm going to say this is what programming is. Programming is a series of mini experiments. And this is what programming really is, that lead us to discoveries. And honestly, this is what programming is to me. Programming is a series of mini discoveries. And to be honest, this is the reason why I'm still a programmer today. Because being a programmer is like being a kid in the candy store every single day. You go to work, you learn, you discover, you understand, and you never go really sit down and just write code boringly and it's like, gosh, this job sucks. I wrote all the code I know. I'm going to go home now. No, we discover, we experiment, we figure things out. Well, if that is what programming really is, how in the world can I write a test first when I don't even know what I'm implementing in the given time? So if it is something you've done a million times over, maybe you should reuse it, not rewrite it. But if you don't know how it's working, don't do test first in the beginning. So what should I do? How should I make it work really? And the answer to that really is to spend the time on this activity called spiking. So in other words, you cannot write a test or series of tests on a very large unknown. It just doesn't make sense to do it. So what you want to do is you want to take very small steps. You want to divide and conquer, but the most important thing is you want to spike to learn. And spiking to learn is one of the most important phases that we tend to forget when it comes to automated testing. So when I sit down to write automated tests, to give you an example of this, I wanted to write a piece of code that integrates with Amazon Cloud to push a particular file on the cloud and manage this. And in all honesty, I have never, ever done this in my life. And I said to myself, I'm going to write a test before writing this code. I'm like, my gosh, how do I do this? I don't have a clue. So I left my project right here, leave it alone, and then walk over here to a separate directory, and I created a standalone project that would allow me to purely experiment. And I spent the next 15, 20 minutes writing a piece of code that will push this kind of file to Amazon Cloud with the type of requirements I had in mind. And once I got that working, it's no longer an unknown. I've taken the time to experiment. I've taken the time to explore. I've taken the time to program it. And now I left the code right here, walked over back to my project, and now that unknown is not a series of unknown, those are a series of known in my mind. I started writing tests and writing code. There are two benefits I got out of this. The first is that little experimentation, the spiking I did, was a throw code. I should throw away that code. And it was just a little mini experiment. But the code I'm writing here is going to go into production. The tests were driving the design of this code very differently than the little spike that I created. Second, later on when I had to come and make changes to this code, it's been in production for about 7 years now. I've made several changes to it over the years, and every single time, those tests are the angels on my shoulder. They tell me that the code worked yesterday, but they work today as well, and that confidence it gives me is enormously powerful. So a lot of times the reason we have difficulty writing these automated tests is we don't take the time to do spiking, but by spiking to learn and then come back and write that test really helps us a great deal in doing it. So is it possible to even write automated tests on something like JavaScript? And the answer is absolutely yes. And as an example, here's a sample of taking a piece of code from all the way down to the MongoDB in the bottom, all the way to Express Server in the middle, and all the way through Angular 2 on the top and to HTML. And in this little sample, these are the number of tests at each of these levels. More tests in the bottom level, fewer tests as you go up. And that's exactly what I captured when I was writing the test driven JavaScript applications. Essentially, the aha moment for me was to really learn and figure out it is not just a theory, but we can actually do this. And having done this on some client projects, it's to really bring this out and say it is possible to really capture these details and bring it out. So, but what does it take to really be able to write these things? Well, the very first thing is discipline. It really takes discipline. And this really concerns me a lot because it's easy to throw our hands up and say, gosh, my managers won't allow me to do it, or management won't allow me to do it. But remember, we are part of professionals. We are professionals. With all respect, management cannot know the details of what we deal with actually on a daily basis. It's far too technical and low level for them to comprehend this. But if the people who know these things don't drive the change, we have absolutely no hope, in my opinion. So it requires discipline on our part to really effect this change. We need to have the discipline. It takes time. And there are two types of time it actually takes. The first time is the time to write the test itself. And rather than just writing, we are taking the time to write the test. And I would argue that time is relatively negligible in the long run. As time goes on, we gain that time back in not having to deal with the other issues. But there is yet another time we need to really keep in mind, and this is where I see a lot of organizations actually fail. And that time is time to get better at our skills. Now, step back and think about the time you didn't do something and you had to really learn it. Like learning to bicycle, learning to drive a car, learning to play piano, whatever it is. You had to take the time to practice and practice and practice until you got better with it. Test-driven development is a skill. And a lot of times, organizations don't give enough time to get competent with that skill. We try to write a few tests, and then we hate it right away, and we don't get the speed. And that's like getting on the bicycle for 2 minutes and saying, gosh, I would never be able to ride a bike, this sucks, and get off of it. So we have to really invest the time to learn. That learning time actually is very significant and time-consuming as well. It also is a skill, and learning that it's a skill we have to develop is something that really gives us the ability to say, it's just another skill. If I put myself into it and practice it, I can get better at it. And it's a skill that we're going to get better at it over time, no doubt about it. And of course, it's also a culture. It's a culture of caring about what we do. In some organizations, there is that culture where people take pride in developing things that are of quality, and for us to really seek those organizations and to build those organizations as well becomes very critical. But I'm going to say automated verification is the software equivalent of exercising. If I ask people in this room, and you don't have to raise your hands for this, but if I ask you to raise your hand, who here thinks exercise is useful or beneficial, almost everybody in the room will raise the hand. But if I ask you to keep your hand up, if you actually exercise it, very few hands probably stand up. And the reason is we all give excuses. We all have good reasons why we don't exercise. I've got this report I have to write. I got this bug to fix. Can you imagine having to fix a bug and going to exercise? That's not going to happen. I have this proposal to write. I got to slides for my next talk. Whatever your reasons are going to be, I'm not going to exercise today. And when you don't exercise today, the next morning, it's a fresh set of excuses. And sometimes I go for 4 or 5 months without exercising until I begin to feel the pain, and I tell myself I should never do this, and I have to get back on to exercising. But that's kind of automated verification. Everybody may agree this is very important and useful to do, but very few of us have the discipline to do it. I'm going to say, what year are we in software development? Well, no, it's not 2017. I'm going to say we are in 1820 of software development. Because if you look at year 1820, the year 1820 was very significant in the medical field. In the medical field, in the year 1820, the mortality rate was very high after surgery. If somebody went into surgery, if they did not die during surgery, they died within 3 weeks after surgery. If a friend of yours comes to you and says, I'm going to have a baby, should I have a baby in the bathtub or should I go to the hospital? You may tell your friend, bathtub is better, you will survive. And that is the way it was back in the 1820s. And the reason for that was largely unknown. The hospitals in major parts of Europe, and especially in the UK, they thought something was bad in the air. They used to keep the windows and doors open in the middle of the day to clean the air, hoping that patients will not die so much, and they just didn't understand it. A guy, Semmelweis, a Hungarian, had a kind of an inkling. He didn't have a proof for it at this point. But what he started doing was he started really boiling in hot water all the instruments he was using, and then he would perform surgery with it. And his patients died very less compared to a lot of other doctors. And he was one of the very first people to propose the thing called germ theory. Unfortunately, he didn't live for too long. They killed him eventually. And that's what happens when you try to speak sense into the crowd. It becomes really hard sometimes in the world we live in. And a few of us really get together and say, maybe this is a better way to do. And some of those guys were these two guys, Joseph Lister and Louis Pasteur. And what they did was they said, hey, maybe there was some truth to what he said. And they started experimenting and looking into this more. And these people really brought together some of the changes we live today in terms of how things are being sterilized and how they started reducing germs. They, especially Joseph Lister, was one of the people who went into the establishments and said, hey, doctors, do you know why your patients are dying? Back in time, some of the really good doctors were really known for how big surgeons they were based on the amount of blood they had on their coat. And so these doctors were carrying germs from one patient to another and actually helping the patients to die. And when they pointed out and they said, you need to be cleaning your clothes, you are carrying the infection. One of the very first things they did was they disallowed these people to practice medicine. So that is basically the world we live in. It takes a lot of time to effect change, but a few group of people will sit together and start doing a better job. And I'm going to say we are in the 1820s of the industry in terms of where we are today in our field. I want to end by saying we are practicing a beautiful craft. Programming is something that is deeply enjoyable. And it is something we come to work every day. And honestly, a lot of us have fun writing code. It is a great, beautiful profession. And we want to continue building on this profession. But it's time for us to take a return into making this wonderful, turning this into a wonderful profession and not just a craft we can become professional by focusing on quality, focusing on creating things that we can stand by, and I hope we can do that. Thank you.